All right, good afternoon, everybody. Just got the cue from my director that we are going live. So I want to say good morning to everybody joining us on the Facebook page. I'm meteorologist Lindsey Monroe. We've done several of these 13 weather academies across central Indiana, but this is the first time we're doing it digitally or virtually. And I'm coming to you from my kitchen. We have everything ready to go. And we're going to do an experiment about halfway through. So there's a couple of things that, as we're thinking ahead, you might want to have ready. So when we get to that section, you can perhaps do the experiment right along with me. So here's a couple things to maybe look around the house. Most of us have these things. You'll need a clear container filled with room temperature water. This can be anything from maybe a big cup or a glass that's clear. Ask mom or grandma if she has a clear baking dish, something like a Pyrex container, that'll work. You'll also need some cold water. So go ahead and put that in the fridge or stick it in the freezer real fast so we can get it nice and cold. You also need some hot water. That can be microwaved. Make sure you have a microwavable safe container before you do that with the help of a parent or a friend or family member who's with you today. And also, we want to show the difference in hot and cold. So I will be using red and blue food coloring, but you can use whatever food coloring that you might have in your house. So we will need those few ingredients and things to get the project, the experiment going. I'm going to use something similar to this. This is going to be the clear baking dish type container that I'm going to use. And then I also have standing by, I've actually frozen some ice cubes with the blue food coloring. So we're going to use this to represent cold air. And then I have some hot water that I just heated up in the microwave. And I'm going to use these food colorings to represent the hot and cold. So we'll get to that in a little bit. We'll be creating an atmosphere that thunderstorms grow in right in our own home. So it's going to be really neat. But first, to get this Weather Academy underway, I want to let everybody know that this is going to be very interactive. I want you to talk to me, and I'm going to hopefully be able to answer your questions along the way. I have my phone brought up here with the WTHR Facebook page on it, so I'm following along live as you're following me along at home. So hopefully I'll be able to answer some questions as they come along, and I'm going to be asking some questions along the way too. So if you happen to know something that I'm talking about, go ahead and feel free to comment on the comment section, and hopefully I'll be able to see that and answer you as we go. So just want to say good morning to everyone who's saying hi on the Facebook page so far. Priscilla saying hi, Belinda, Danny, good morning everybody. We're going to get started without further ado. So let's jump into the 13 Weather Academy. The first thing we're going to do is a show and tell. These are things that you might have seen around your house, or maybe you've used them in the past and didn't necessarily know what they did. Well, these are instruments that we use in the weather world almost daily to help us get observations on what's going on in the world around us and help us put together a future forecast. So let's start with this first one here, and I'm watching the comments. So if you know what any of these are, please feel free to chime in. And parents and grandparents and family and friends, if the kids want to type something in, go ahead and help them out, and I'll give you a little shout out if I see the right answer. So here's the first one. Does anyone know what this is? Very, very common. Very used to using these on a daily basis. This one is a thermometer, of course. This is an instrument we use. It's consisted of a sealed glass tube. It contains mercury or alcohol, and those compounds expand or contract inside of the tube as it is heated or cooled. So as the temperature goes up or down, those combinations will either rise or fall, and that tells us what the temperature is outside. Let's move on to the next one. We have a lot of instruments to talk about today, and this is actually a video. Who knows what this one is? We're talking about the one that's spinning around on the left side of your screen. That one. Anybody know? Looking at some answers coming in on the Facebook page. People saying that you can't see me. That's right. You're just going to listen to me. I'm going to come back on cam at times, but really just want you to see kind of the PowerPoint presentation, and you'll see me off and on through this. So anybody know what this one is? It is an anemometer. The anemometer, very important on windy days because it measures wind speed. The cups you see, the half circles, they catch the wind as it's blowing, and that turns the dial, and that's attached to a measurement instrument And that dial will show us what the wind speed is. Also attached to that in the picture, you can see that arrow pointing thing. That's a weather vane. That's going to help us see what direction the wind is blowing from. Very important if we have a storm system coming in, or if we have a front coming through, to see that change in wind direction. It helps us really forecast what's going to happen in your neighborhood. All right, let's move on to the next one. The next instrument, we use this all the time. In fact, Kelly Green has one in her backyard, and she gives us lots of reports from it. Does anybody know what this one is? It is a rain gauge. These are often hoisted up about 2 meters from the ground, so it doesn't have anything around it. It will get an accurate measurement of how much rain has fallen over a specific amount of time. And this is really important when we have heavy rain events like thunderstorms, because we have to know if a lot of rain has fallen in a short period of time, especially over a small area, that could lead to things like flash flooding. The National Weather Service needs that kind of information to put out things like flash flood watches and flash flood warnings, especially if there are any flooded roadways. We let you know that information. All of that coming from a rain gauge. So there you go. What's next on our list? This one I seem, as I've presented this to classes across the state, gives them a little difficulty because it's something that we don't necessarily talk about a lot on the news, but it's something that we find very useful when we are forecasting weather systems coming in. Anybody know? A lot of people got that rain gauge one. Stacy, Julia, Beth, you got that one right. What about this one? Tells us if it's going to be stormy or if the sky's going to clear as it changes. This one is a barometer. Very, very important because it measures air pressure. It tells us if the pressure is rising or falling. And you might hear Chuck or Angela or Sean or Kelly or myself talk about this during a weather forecast. We'll say, high pressure's building in. Well, that means that there's a lot of weight in the atmosphere pushing down on the surface. So that prevents clouds from growing tall, meaning that the sun will be out because the clouds are going to have a hard time forming. And usually that means dry conditions. Now, if the barometer is falling, and grandmas and grandpas might know this, moms and dads even, if the barometer is falling, that means the pressure is low. So there's not as much atmospheric air pressing down on us at the surface. And that's often when we get those achy bones and joints. But it also means stormy and wet conditions are potentially on the way. And we have a pretty low pressure system that's moving through, which is going to bring us some strong storms tonight and into tomorrow. So that is a very important tool that we use at the 13 Weather Center to tell us what kind of conditions that we're going to see. All right. Lots of good answers coming in on the Facebook Live here. So thank you for interacting with me. I'll try to call as many out as I can as we keep going through here. All right. As we know, we're now into spring. And this is really important. This is a really important topic because we can see severe weather here and really all year round. So spring is when we get the highest frequency of not only thunderstorms, but strong to severe storms. In fact, we have a risk of severe storms tonight as well. So this is why we want to make sure everyone's kind of aware of what can happen in the atmosphere around us and kind of what's going on to bring us these spring storms. First of all, tornadoes. This is the biggest question we get when we go into schools. We want to talk about tornadoes because they are wild to see, not only on video, but hopefully you've never seen one in person or been close enough. They can be scary, but let's talk about how they form so maybe we can better understand why it's happening. Tornadoes are rotating funnel-shaped clouds, and they're not technically a tornado until they actually touch the ground. They've been reported in every state. They can happen at any time of year. And folks that we've talked to who have experienced tornadoes say that they often sound like an airplane or the sound of a roaring train. There's also some myths out there about tornadoes. Some folks believing they are not susceptible to seeing tornadoes or getting one where they live, but let's debunk some of those myths. Tornadoes don't happen in winter. Well, that is a myth. They can happen at any time of year if the conditions are right. In fact, just a few years ago, in November, we had some very strong storms through central Indiana. A few of them produced tornadoes. And technically November isn't winter, but It's definitely not spring. It's definitely when we wouldn't expect to see tornadoes. So that's why we need to be prepared for them at any time of year. Another myth that we sometimes hear in the weather world is that tornadoes never hit the same place twice. Well, we know this is not true because let's take Xenia, Ohio, for example. This city was hit by a very strong tornado, as you can see in the picture, in 1974, but just a few years ago, the same town had a ton of damage because of another large tornado in 2018. So just because it's hit one spot doesn't mean that same spot's not going to get hit again by another severe storm. And another myth, in fact, this one recently had another example. Tornadoes never hit big cities. We know for a fact this has happened in many large cities. Miami, Salt Lake City, and Fort Worth, Texas, and most recently in Nashville, Tennessee. You may remember a few weeks ago, this actually happened overnight. Nashville downtown had a ton of damage, in the northern suburbs and a big area of Tennessee experienced some strong storms and tornadoes. We actually want to talk more about those Tennessee tornadoes and go back and kind of revisit what the radar looked like and how some of those things that we saw on radar with those tornadoes, you might end up seeing this spring.
We want to show you what this looked like when those storms rolled through. And we're going to back up radar to 1:30 this morning, Nashville time. Obviously, they were dealing with storms, but some of our enhanced abilities with the radar to pinpoint where the rotation is. And we can do that with this little circle. That SHEAR marker shows the rotation. Also being detected just to the southwest of that SHEAR marker. One other thing with this intense storm is what you see just southwest of that circle is what we call a debris ball. What is a debris ball? A debris ball is basically that debris being blown up in the air thanks to this tornado. Okay. And so the debris ball was visible on radar. What other thing we noticed, Scott, is as we take this radar 3D or three-dimensional, you can see the debris being blown off to the east with this storm. And this is a huge area that you're talking about. It is a huge area. It wasn't just developing west of Nashville and then obviously traveled north side and hit the east side of Nashville. But check out all of these communities near and around Nashville from about 1:30 in the morning to 3 a.m. This again is that rotation tracker showing all of the rotation with this tornado. And unfortunately, a lot of damage as we've seen the pictures. And all of this happening in the middle of the night as people are sleeping. And we know from being in Indiana that is the worst time to have a tornado happen because it leads to the fatalities. But do know, when and if we have situations like this, we have this ability to show you to help keep you safe. This really helps, I think, our viewers understand what is happening, certainly in Tennessee, and what possibly could happen here in Indiana. And we've got you covered. All right, Angela, thanks.
All right, everybody. So that was just a little clip from Angela recapping those Tennessee tornadoes and the one that actually hit Nashville and some of those radar products. So some of the things that you'll see on radar that we will use if we get severe weather where we live. These are very important. And this is a good question that I ask a lot of my classes. Do you know the difference between a watch and a warning? Feel free to weigh in. I want to see some of your responses on our Facebook page. A lot of people joining in now. If you're just now joining us, feel free to chime in at any point. But I do want to talk about watches and warnings first and foremost. Watches, typically, they are issued first because we can monitor the atmosphere. The watch is issued from the Storm Prediction Center, and that center is in Norman, Oklahoma. It's a big area of meteorologists that work together specifically studying severe weather. They're the ones that put the watches out. That means the conditions are right for storms to develop in the area that the watch is issued for. At this point, well, we just want to be prepared. There's nothing that's out there yet, but we want you to stay tuned to Channel 13 and make sure your parents have the Live Doppler 13 app on their phone. Of course, that's free. They can customize these alerts. And as well as NOAA weather radio, because these can be battery operated. So in the case that your power goes out, your phone may die, you're still able to get those alerts because of the battery operated weather radio. Now the warnings, these are very important that we know what these are. Severe thunderstorm or tornado warning means there's either a tornado that is on the ground, it's been detected by Doppler radar, or we have a trained storm spotter or law enforcement. They've seen this. They call it into the Weather Service and immediately a warning is issued. We need to take action at this point and seek shelter immediately. A lot of folks are saying, yeah, Michael saying, watch is be aware, warning is weather is nearby. Very good way to think about it. Warning is when we need to take action. But what do you do when we say take action? We need to have a plan in place. And this is really important for kids to study in school. They know where to go. If there is a tornado alert, they usually go into the hallways away from windows and cover their heads. Classes are really prepared with this. So I know the schools are doing a pretty good job of making sure that the training is working. But these are conversations that we can have at home with our parents, or if we stay with our grandparents and family members. If there is a warning issue, we need to take shelter. The best spot, obviously, is the basement. But I know a lot of people don't have basements. We say the basement because we want to get away from windows. We want to put as many walls between us and the outside as possible, so we don't have flying debris that could potentially go through a wall or break a window and shatter glass. So if you don't have a basement, you see right next to the stairs, well, that's a closet. Closets are a great place to go because they don't have windows, and there's often several walls between you and the outside if you're inside of an interior closet. Also, bathtubs are a great place because you're usually far away from windows there. And not a bad idea, if you have a bike helmet, if you ride bikes this time of year, not a bad idea to go ahead and grab that bike helmet and just throw it on just in case something might be coming down from the ceiling or something like that. It's just added protection. Anything that you can do to protect your head, always a good thing. So those are some of those conversations that I hope that you can start having with your families so that we know that everyone will be safe and do their best if there is a warning that is issued in your area. Get in and get down. Let's talk about some products. So we just watched that video with Scott and Angela talking about what you could see on radar. This is actually a video that I believe we can play, and it shows where we look as meteorologists, some rotating thunderstorms that would potentially be apparent to issue the warning.
I'd be shocked if this thing might be on the ground right now, just south of Crawfordsville, west of Mace and Whitesville. Now east of 231 is where we're getting the signature there. They see the red is the outbound wind and the green next to each other, that's the inbound. So that would be where we have the tightest circulation. That's going to be right in this area right here is where the storm's rotating. This is moving.
All right, so that was Sean actually doing live coverage of a tornado warning a couple of years ago near Crawfordsville. It was very apparent that there was rotation on radar. The warning was issued. And guess what happened? Yeah, there was a tornado that dropped out of this thunderstorm, and we have a video of it right here. So this can play. And actually what happened in this particular storm is we had a crew out in our live Doppler 13 mobile storm tracker from really a safe spot, but then this thunderstorm essentially developed into a tornado, and they were within a safe distance so they could capture this on video. And you can see this thing really impacting the ground and spinning fast. It was the same storm that we just showed you on radar. So we have a lot of good technology where we can pinpoint exactly where these rotating storms are, even almost down to a road-by-road basis where you live in an even particular neighborhood. So yeah, some folks weighing in, they remember seeing this video. They remember that coverage of that storm when it happened live. So these are the kind of things that we could potentially see as we head into the spring severe weather season. That video captured by some of our crews. But we want to kind of talk about why this happens. What causes a tornado? You know, we have severe weather, we have storms, but what causes it? What's going on in the atmosphere that causes these violent rotating columns of air? Well, there's a couple of things going on. We have to have all the ingredients come together perfectly in order for a tornado to form. Here's the first step. This is what we need. We need something called wind shear. Wind shear is a change of wind direction with height. So for us here at the surface, we might notice a southerly wind, but just above us, we might have a northerly wind. The wind directions going in opposite ways will cause spin in the atmosphere that will create a column of rotating air in between the changing wind directions. So that's what we call the rotation setup. Watch what's going to happen as we have this cool air It is more dense, it is heavier, it sinks closer to the ground. We have this warm air close to the surface wanting to rise, and that's we get the rotation. But it doesn't look like it's going the right direction, right? It looks like it's a horizontal rotation. Well, add the thunderstorm into it, and that's where we get that spin to rotate more vertically. The thunderstorm cloud itself acts as kind of like a suction cup. It's wanting to suck up all of this air close to the surface, and as it's bringing all that air upward into the storm cloud, it's taking all of that rotation in the air and it's flipping it onto its side, which is what gives us these vertical storms, these tornadoes, as you can see in the video there. I want to recreate this in our homes. I don't want to do a tornado per se, but I want to recreate the atmosphere that we need in order for these storms to happen. So now is the time, if you have all of those ingredients, that we're going to make an atmosphere that will do something like this. It's going to be called a convection current. It's where less dense warm air will sink, or I should say rise. The warm air rises and that colder air sinks closer to the surface, creating a thunderstorm atmosphere is going to be our experiment for today. And I was told that for some reason, I don't know if it's my Wi-Fi or if it's where I'm at in my kitchen, I'm not getting a good internet signal, but I might be a little blurry. But just deal with me here and we'll get through this experiment. So I want you to grab some of the tools that we talked about needing. You'll need this clear container. You'll also need some cold water with your blue. The blue goes in the cold, the red goes in the hot. And I will move my camera now. This is a webcam, so it might be a little jiggly as I move it. But I want to set it up right here to kind of show what we're going to be building. So this is my clear container, and I have it filled with just regular room temperature water. And then this is my hot water here. I put it in the microwave, less than a cup, for about 3 minutes to make sure it was good and hot. It's still pretty hot. I might just stick that back in the microwave for another minute or so. All right, so while that's cooking, let's talk about what I did here. So these are my ice cubes. I just used blue food coloring. I wanted to make sure they were nice and cold. So when I put it in a room temperature or a neutral atmosphere, which is what this is going to represent, it will sink to the bottom because it is colder than the air around it. So let's start and see what it does. Do you see as it starts to melt, the blue is sinking toward the bottom? Because that air or that water is colder and it's more dense than the air or the water that's currently in the container. So it's starting to go toward the bottom. You can see that there. All right, my hot water's done. The hot water, I'm just going to add 2 to 3 drops of red coloring. And stir it up good. So what's going on in the video right now would be if a cold front was coming through and colder air was taking over a pretty warm atmosphere, it will undercut it. It'll go close to the surface. Now let's add some warm air to the mix. You can see the two air masses already starting to come together, but look at the red. This was doing a really good job. The red air is a lot less dense, so it's a lot lighter. So it's going to go to the top, and look at the blue, that cold air really starting to melt in as the two air masses mix. This is a really good example of not just what the atmosphere looks like when thunderstorm clouds develop, but it's a really good example of a lot of different things in the world around us. Think ocean currents, for example. This is how they form. It's a collision of cold ocean water and warm ocean water, and it gives us those currents. Why we have colder air off the coast of California and mild temperatures near Florida. Also, think about if you live in a 2-story house. It's always warmer upstairs, or at least it seems to be. That's because the warmer air will always rise up and the colder air will always sink down, and that has to do with density. It's also how we can predict thunderstorms. So if we see a lot of warm air going over a colder surface, then that's a good representative that we're going to have what we call convection or storm clouds growing because there's a lot of energy in the atmosphere, and that's going to give us the tornado, the rotation, potentially the severe weather as well. So this is that example back, as you can see in the diagram, of what we just created in your own home. And I will go back and kind of post more about this and talk about how you can make this again at home just with the ingredients that I showed. Again, it just takes a couple of things. I will say this though, if you didn't get it to work perfectly, it works better if you do have the ice frozen with that blue food coloring. It doesn't necessarily work as good if it's just cold water. So if it's closer to frozen or ice, that's going to work a lot better. But that is our experiment for today, convection currents. Hope you learned a little bit about how the atmosphere kind of works. Good stuff there. We have a lot more to talk about though. Let's move on in our presentation. We're talking all about severe weather and storms. Here are a couple really cool things that you're going to see from the 13 Weather Center. Hopefully you don't see it all that often because it will involve storms, but this is a neat new tool that we have. Let's put this into motion because this 3D radar actually allows us to analyze storms, not just from the surface, but we can see how tall these storms are. Look at those reds and those yellows. That's picking up on things like hail cores. The taller the thunderstorm, the stronger it's going to be. That means we could see areas of hail, and as you can see it going up in the atmosphere, the taller the thunderstorm, that really does help us predict who's going to see what kind of intensity, even as far as rainfall goes. A really neat tool that you'll be seeing this severe weather season. Another one that we have has a lot to do with rotation. Now, this is when we would be forecasting tornado type situations. It's called the shear rate. We talked about that wind shear, that change of wind speed or wind direction with height. This is a tool that actually picks out where that strongest rotation is and maps it out for us. So on this particular storm setup, you can see we had some very defined rotation right there along US 31 and 465. We can map this down to street level so we can exactly tell folks that are in the path of this that they need to seek shelter because we are seeing the strongest part of the storm in their area. So that's our shear rate tool that you might see. And again, it has to deal with rotating thunderstorms or the storms that have a highest probability or chance of producing a tornado. Here's another one that we've been using. It is our shear markers. So this is a new tool that we really haven't used all that much, but Angela actually talked about it with those Tennessee tornadoes. What our radar is going to automatically do, it will see where these storms are starting to rotate. Now, this doesn't mean that there's a guaranteed tornado being produced or on the ground, but it gives us a good indication of the thunderstorms that are starting to rotate and ones that we really need to watch out for. And we can do this well in advance of a warning being issued. So this will help us be able to communicate that there are storms that could potentially have a tornado in them. We want you to seek shelter now, well in advance of that storm moving into your area. So that's the shear marker. You might see that. Okay, now this one is something we may have heard of before. It's called a hook echo. I want to see folks chiming in. I'm seeing a few people kind of mentioning what they're doing with this. Yeah. Kids having a good time with their parents, I see. Thank you so much for joining me. But, you know, parents, this is something that has been around for a while. This isn't new technology. This is what we would look for the very earliest radars. It's a hook echo. And I want to break down this supercell thunderstorm of what is going on inside of this hook echo shape and why it looks like this. The echo itself forms when we have a lot of warm surface winds being kind of sucked up into those thunderstorms. We talked about that when the rotating air went from horizontal to vertical, the thunderstorm is sucking up a lot of air into it. Well, that's what causes that notch. That's what causes that dry air to kind of move into the thunderstorm. And within that, we could see things like debris balls, and that's where the tornado would be. It would be in the very southern edge of that, where you say the debris ball is located. On the northern extent of that, and this is where storm spotters get in trouble. They get caught in this rain shield that's out ahead. You see all of that rain on the radar, and embedded within all of that rain and where the hook echo itself is where the hail core would be. Some folks might have seen this outside. If you go outside during a thunderstorm before it gets to you, you might notice a green cast to the air or to the sky. Well, that green cast that you're seeing is actually the light reflecting off of ice in the clouds where the hail core is of the storm. So that's something that if you do notice a green sky, that means there could be hail in the storm headed your way. Definitely time to head indoors. So that's the hook echo of the storm. And we have to communicate this with you somehow, right? This is how we bring the weather to you. You may have seen us on air in times of severe weather. That's us in the studio with Angela and Sean. And while most of us are working from home right now, we want you to know that we are still going to be with you in studio if there is severe weather. We want to make sure that we have that backup generator and we have all of our tools at our disposal if there are some severe storms. So we will, of course, make sure that we have that access to the studio if we do see severe weather here locally. Now, over on the other side of the screen, you have Chuck doing a Facebook Live, which is very similar to what I'm doing with you right now. A lot of us are on Facebook. We get the alerts almost constantly these days, but this is really important because it's just another route or avenue that we can take in order to deliver that message in times of severe weather. Hi, Eileen, saying good afternoon or good morning. What time are we at? 10:48. Good morning to you. Melissa, thank you for joining us. I appreciate having you on this afternoon. Feel free, again, if you have any questions, to go ahead and message in that comment section. This is a very open forum here to communicate some weather information with you. So this is how, again, we bring the weather to you. A lot of us have this Live Doppler 13 app, and I've talked a little bit about this, but this is actually a nice way to get the interactive radar where you can zoom in exactly where your neighborhood is and see how the storms are moving through. You can put that into motion. It's all interactive, and it's also where you can get those customizable alerts. And then our Live Doppler 13 storm tracker, and this is what they were out in when they captured that video of that tornado. It's a great tool that we have in order to get on location and see the storms from a safe distance. Remember, we don't chase them, but we monitor them, and we can get you that local video whenever those storms do happen in central Indiana. And of course, I know it's kind of hard to do right now since none of us are really in school, but stay in school, really important. Some of the things that I studied a lot when I was going through college was math and science, and I was never really that good at math, but I learned that if I want to be a meteorologist, it's going to require me to do a lot of it. So stay in school and make sure that you study math and science, and this is something that you're really interested in. Now, I know there's going to be a ton of questions. We always get this at the end of the presentation, but we're not quite done just yet. In fact, we asked some questions from the Indiana Fever. If you've ever been to an Indiana Fever game, it's our WNBA team here in Indianapolis, and they actually came up with a lot of good questions as well. So we're going to start with them. You might be wondering the same thing, and if you know any answers to their questions, feel free to post it in the comment section, and I'll give you a little credit for knowing the answer. But let's go ahead and check out this first question and see if we can answer it.
Now here's a real slam dunk. What does the weather have to do with potholes?
Does anybody know? Potholes are quite common, especially in the late winter and early spring. And I have a video that I want to play and kind of show you the demonstration of how the weather does impact the roads and how potholes are caused. So the cars will continue to drive over our pavement and our roadways, and they cause cracks from time to time, just general wear and tear. But when it rains, that rain will seep down through the pavement and the water will pool under the road surface. Well, then winter comes, this water freezes, it expands, and it weakens the roadway. And that roadway is forced upward. Now, when it gets warmer again, temperatures above freezing melt that ice. And then that continues to break down our pavement. Constant traffic will break down the road surface, and that's what causes these potholes. So they are almost directly related to the weather. It's a combination of rain, freezing, and thawing, and we typically see that a lot in the winter months. Late winter, early spring, so we've actually had a lot of road crews, and this kind of slow traffic time has been really helpful for our road crews to get out and patch potholes and also start some early summer construction projects. So that's that one. Here's another one.
When the fever hit the court, we hit like a fast-moving tornado. Do you know what they call a tornado that's over water?
Now, I know some of you know this one, and I'm going to give you just a second to comment in on our Facebook page because this is a pretty common one, right? We talk about these all the time when tornadoes happen over water. Does anybody know? I'm getting a couple of answers from the pothole question. Beth did a good job on that one. I'm going to wait to see if anyone responds. But essentially what happens, it's a little different setup. The thunderstorm obviously develops over water, and the same kind of concept happens. We have the sea breezes at one direction close to the ocean's top layer, and then just above that where the thunderstorm comes in, it causes that rotation. So it's essentially the same thing. It just looks a little different because it doesn't have any debris like dirt and limbs from trees and parts of homes to pick up. So it's all made out of water, so it's a little bit different. And that answer is a waterspout. Waterspout is just a tornado over water. All right, next question.
You know, our colors are fever red, blue, and gold. But have you ever wondered why clouds are white?
Yeah, it's a good question. And want to give a shout out from Brody. Allison posted on behalf of her son Brody and saying that was a waterspout. So good job. You get a gold star for answering that one correctly. This question, though, is asking, why are clouds white? What's going on in the atmosphere? And I have a little demonstration, and I'm going to actually use my backlight, so you might not be able to see me super great for just a second, because I'm going to use this to demonstrate. So this is the light I've actually been using to make sure you can see me. We're going to pretend like it's the sun. Now, the sun is always bringing rays to the surface, and the clouds are essentially just like water vapor or smoke. So if it's going through here, you can see that this is reflecting white. You can see through it. However, if we have a cloud that is full of moisture and it's a little thicker, and then we put this up to it, it's not going to shine through it as much. As you can see, you can't necessarily see the white on the other side of the paper towel because it's not letting the sunlight through because it's a thicker cloud. And that's why when we have cloudy days, we often can tell it's going to rain because these clouds are thicker and not as much sunlight is being allowed to penetrate through the clouds. So that's why they appear to be darker. So that's all the questions that I have from the Fever team. Now is the time for you to ask whatever you want. It doesn't have to be specifically weather related. It can be about the TV business, how I kind of got to where I am. I can talk a little bit about where I'm from. I'm from Central Indiana, right here in Wayne County. I grew up in Cambridge City. Went to Lincoln High School. I have a lot of family members on here watching today. They know what I'm talking about. Then I went to Ball State University up in Muncie, Indiana, and I studied there for 4 years, and I got a degree in meteorology and kind of moved for a couple of places, started working over in Terre Haute, worked down in Memphis, Tennessee for a few years before moving back to Indianapolis. So it's been a little bit of an adventure to get back to Indy, but I grew up watching WTHR, and it was kind of a dream of mine to get a job back here. So it's kind of good timing to be back in Central Indiana. I had a question from Melissa asking what causes hail. If you think about what goes on inside of a thunderstorm cloud and why we talked about the taller the cloud, the tendency the storm is to be more severe. What's going on inside the cloud is an updraft and downdraft. As it brings all of that air in from outside of the storm cloud, that's what we call the updraft. but it can only go so high before it starts to fall back down, and that's the downdraft. So if you think about the circulation that's going on within the cumulonimbus cloud, it's our thunderstorm cloud, there's a lot of cold air up there, and we have these water droplets that will essentially just cycle through and through these updrafts and downdrafts, and that's kind of how the hail starts to grow. And the more powerful the updrafts and downdrafts are with wind speeds inside of them, then that's going to be able to retain these bigger ice balls and essentially just keep growing and growing until the updrafts and downdrafts can no longer support these balls of ice, and at that point they'll start to fall to the ground in the form of hail. So it takes a very specific type of thunderstorm to produce large hail, and unfortunately it does look like we have that setup that could go on tonight. The line of storms that we're forecasting will potentially produce some large hail, and it's going to be mainly while most of us are sleeping between about 11 p.m. and 4 a.m. So if you have anything outside, if you keep your vehicle outside, perhaps pull it into a shelter if that's possible, or if you don't want anything damaged, we just encourage you whenever we have hail events or the potential of hail to make sure as much stuff is brought in as possible. Stacy is asking, do the debris ball on radar indicate that there is really a tornado on the ground, or does it just mean that there might be one? I know spotters are vital to give ground truth, but radars are good enough now that they can indicate that there is a true tornado on the ground when there is a debris ball. You know, there's a lot of tools that we use. We can do that SHEAR tracker that we talked about, the velocity, where we can see the rotating winds on radar. But really the true sign that there is a 100% chance there's a tornado on the ground is that debris ball. You know why? Because we have to have that storm hitting the ground in order to pick up debris and loft it into the atmosphere. So that's what the radar is picking up on at this point. It's picking up on the difference in a water droplet or a non-meteorological target, like a piece of a tree or a piece of a house or something that's not liquid or ice. And we can measure that because the pulses that the radar is sending and hits that object, and when it comes back, we can tell that's not ice or water, it's something else in the air, and it will color code it a little differently. So if we see that debris ball, that's one of the few ways that we know almost for a fact that there are a tornado could be on the ground. Let me see here. How do you measure the EF scale for tornadoes? This is a really good question because it was actually updated in 2007. Before, it was just the F scale, the Fujita scale, and that was based off of a wind measurement. But what Dr. Fujita measured in 2007 when this new scale came out is it's a more accurate measurement to see the damage that is caused because of a tornado and then classify that damage to put the scale into play as far as the ranking of the tornado. So what storm assessors do, the National Weather Service office, they'll actually go out to these locations where the tornado hit and did damage, and they'll assess, were things twisted around? Are tree branches here, are they blown over to the side, or are they twisted and thrown across the way in a different direction? Well, that shows there's some rotation, and it's just a matter of how far that tree branch was thrown. It's a matter of how much of the house was ripped off. Was it just shingles on the roof, or was it the entire roof plus some windows? So they take all of that damage into consideration when they give out these EF ratings. And one tornado could go through a series of different ones. It could start off as a EF1, and then a small little area of the path could be EF3 damage, and then it go back to EF1. So one tornado could technically be multiple different scales, but they will be ultimately named by the most widespread damage. So if it at any point on its path shows EF3 damage, and that's the scale rating that that tornado will get. All right, and there's questions about this, and this is a perfect question to wrap up on. Beth asking, will you do this again? Yes, we would love to. This has been a great opportunity to chat with you at home, but it's not going to be me. It's going to be Chuck, and it will be Angela, and then potentially Sean and Kelly down the road. Make sure to join us back here on the WTHR Facebook page at 10:15 on Tuesday mornings, or you can find us at WTHR.com/Weather Academy to watch at any time. Have a great day, everyone.